In this video, we shall talk about the pendulum clock, an engineering marvel that revolutionized timekeeping for decades and was paramount to managing our time and fulfilling our appointments. Before we delve right into the working of it, we better recap some concepts which are instrumental to understanding the principle of a pendulum clock. Many kinds of motions repeat themselves over and over. The sound vibrations produced by a clarinet, a ball rolling back and forth in a round bowl, the revolution of the planets around the sun are just a few examples that constitute periodic motion. On the other hand, bodies undergoing oscillatory motion are characterized by a stable equilibrium position. When it is moved away from this position and released, a force or torque comes into play to pull it back towards equilibrium. Picture the oscillation of a simple pendulum or a loaded spring bobbing up and down in the vertical plane. An important thing to be noted here is that all oscillatory motion are instances of periodic motion, but the converse does not apply. All objects when enacted by an impulse vibrate at a particular frequency. If you drop a meter stick or a pencil on the floor, it will begin to vibrate. Similarly, if you pluck a guitar string, it will vibrate as well. An object's natural frequency is the frequency or rate that it vibrates naturally when disturbed. Objects can possess more than one natural frequency, which are usually whole number multiples of the fundamental frequency. The natural frequency is an inherent property of the mechanical system. An oscillating system would keep oscillating regardless of the magnitude of initial energy provided. Dissipative forces such as friction and air drag don't affect frequency, but merely dampen the amplitude of vibration. We now travel back in time to the 17th century Italy, where the first notions of a pendulum clock were conceived.
Okay, so the concepts discussed so far were taken into consideration by Galileo, and he came up with the idea for a pendulum clock in 1637, which was partly constructed by his son in 1649, but neither of them lived to finish it. Then came the Dutch scientist Christian Huygens. Inspired by the investigations of pendulums by Galileo Galilei, Christian Huygens invented the first pendulum clock in 1656 and patented it the following year. The construction of the clock was carried out by Salomon Koster. He was the one who actually built the clock. The introduction of the pendulum clock increased the accuracy of clocks enormously. And by enormously, I mean the errors reduced from about 15 minutes per day to 15 seconds per day. And since it was the first harmonic oscillator used in timekeeping, until the 1930s, the pendulum clock was the world's most precise timekeeper. However, later on, it was replaced by less expensive synchronous electric clocks in the 1930s and 40s. Now, the pendulum clock comprises of 5 key components. The first one being the dial and the hand. So, a dial and hand indicate the time. Then comes the weight. A weight stores potential energy and releases it to the clock mechanism as it falls, very gradually over the course of a day or several days. And by winding the clock, it raises the weight back up, storing more potential energy to power the mechanism. Then we have the set of gears. So a set of gears take energy from the falling weight and use it to drive the clock mechanism at the correct speed. Then we have a set of timekeeping gears. So timekeeping gears are usually finer and more precisely made than the power gears, and they drive the different hands around the clock face at different speeds. And lastly, we have the pendulum and escapement. So the pendulum and escapement regulate the speed of the clock and keep it more or less constant. Now let us have a more detailed overview of the working of the pendulum clocks.
Before we move to the practical functioning of a clock, let us look at some of its individual elements, such as the escapement mechanism and how it works. One of the most fundamental components of a clock is the escapement mechanism. It harnesses the power from the suspended weight. The way this works is, the weight coils around an axle behind a gear, such that when it falls, it unwinds and rotates the gear, sort of like a spinning top. The escapement mechanism of the pendulum prevents the weight to just whiz down and instead acts like a valve to slowly channel energy into the pendulum by giving it a nudge every rotation, which keeps the pendulum swinging. As we can see, the gear rotates every half oscillation of the pendulum. Thus, we can use a pendulum which has a time period of 2 seconds. This gear that turns every second essentially gives us our second hand. Now that we have discussed about the different components that play a pivotal role in the functioning of a clock, let us look at how they are incorporated by taking an example of a working pendulum clock. The clock and frame consists of a power source that provides it with a steady flow of mechanical energy in order to run smoothly. The power source may be in the form of a weight or a spring. And in order to channel this abundance of energy, an escapement mechanism is incorporated to slowly utilize the energy in small portions. The anchor visible on screen moves the escape wheel in contact by just one tooth each time. The timing of the escape wheel, and effectively the entire clock, is dictated by the oscillation of the pendulum, which is perhaps the most vital element in the entire instrument. The crutch connects the pendulum to the escapement, thus ensuring that they work in tandem. And in turn, the escapement supplies power to the pendulum to prevent its oscillations from damping over time. The rotational frequency of various wheels in the clock is controlled by the escape wheel pictured on screen. The ratios of all the gears present are selected such that any one wheel has a time period of exactly 60 minutes. Thus, the minute hand and the hour hand are attached externally to the rest of the clockwork. They are visible from the outside and indicate the correct time of day. Why then did this incredible instrument become a forgotten piece of technology? Here are some of its drawbacks that called for its replacement by more advanced clocks.
Though the pendulum clock is an incredible feat of engineering, its design do have some major flaws. The biggest being changes in temperature would cause the length of the pendulum to change, which resulted in varying of the time period of the pendulum, thus messing up the calibration of the clock. These clocks could not be used on ships because the swaying of the ship would affect the swinging of the pendulum, which was a massive drawback in the age of sea exploration. Also, you could not use the clock in a place with different gravitational acceleration than from where it was originally made, like at different altitudes. These clocks were very bulky and very difficult to transport. Pendulum clock isn't just antique, it's a heritage of timekeeping, a milestone in the ongoing quest of more and more accurate time measurement. They tell us an incredible tale of human ingenuity. We are so much more than just a technology lost in time.